Dividing rational numbers is almost as easy as multiplying rational numbers. Generally easier than adding or subtracting. And you probably have already learned the rule. When you're dividing by a fraction, you can turn it into a product. In other words, you can just multiply by the reciprocal of that divisor fraction. But you may be wondering, why can't you just do the same thing you do with multiplication? In other words, why can't you just divide the numerators and divide the denominators? Well, it turns out you can. So here in this example, we've got 25 over 36 divided by 5 over 12. And, why not just do 25 divided by 5 on the top and 36 divided by 12 on the bottom and end up with 5 over 3. Now, does this really work? Well, let's do it the conventional way that you probably already know and see if we come up with the same answer. So if we have 25 over 36 divided by 5/12, we can turn that into a product just by taking the reciprocal of 5/12, which is 12 over 5, flipping it in other words. And here we can see there's a lot of cancellation we can do. Remember, you don't want to just blindly multiply the numerators before trying to figure out if you can cancel anything. And the 25 and the 5 obviously share a common factor of 5, so that leaves us with a 5 on the top. The 12 and the 36 share a common factor of 12, that leaves us with a 3 on the bottom, and we end up with 5 over 3. So we end up with the same thing. So the question becomes, well, why can't we always just do this first method? Well, it turns out it's got to be a pretty special example for it to work in the first method. The last thing you want is to have a fraction where the numerator itself is a fraction or the denominator is a fraction or both are fractions, because then in a sense you've just created more work for yourself. So this really only works out when the division performed by taking the numerators and dividing one by the other and the denominators yields integers. And so it's not really going to be a very useful technique, but every once in a while you'll see it and it'll save you some time. Let's take a look at another more straightforward example, but this one involving mixed numbers. If you have 2 3/5 and you're dividing that by 1 2/5, well, again, it's very difficult to deal with mixed numbers just as they are, and I wouldn't try, but if you convert them into common fractions, it becomes pretty straightforward. 2 3/5 is just 13 over 5, and 1 2/5 is 7 over 5. So we can turn that into a product by just taking the reciprocal of 7 over 5. So we end up with 13 over 5 times 5 over 7. Clearly the 5's cancel out. You have a 5 in the numerator, 5 in the denominator, and you end up with 13 over 7. Now, if you look at the result here, you can see that we actually could have used that nice little trick that I started with for the denominators. And the 5 divided by 5 on the bottom basically yields 1, and it disappears. And what do we get? We get a numerator of 13 over 7, or 13 divided by 7. And that's what we end up with. So I wouldn't necessarily suggest using that technique for this one, but it still does apply, and it's nice to see the consistency.